There are 5 things that you can watch forever: fire, water, modularity, coupling, and cohesion. Let's say you have 10 people who are completely unrelated to each other, and you need to accommodate them somewhere. What makes more sense, putting all 10 into one house with one shared kitchen, or giving them 10 separate apartments? And unless you're strange, the correct answer would be 10 separate apartments, so everyone has their own space. This is modularity. Modularity helps split a system into distinct parts instead of stuffing everything into one place. You're 45 years old and still completely dependent on your parents. This is a problem, because your life depends too much on something outside of your control. If that support changes, your whole life becomes unstable. This is what high coupling looks like. That's why you have to strive for low coupling, which means different parts of the system should not depend too much on each other. The less one part breaks when another changes, the better. Now imagine a family where one person does everything: cooks, cleans, works, takes care of the child, buys grocery, and plans the budget, while you just finished watching the Peaky Blinders. This is a problem, because too many different responsibilities are concentrated in one place. If that one person becomes unavailable, everything starts falling apart. This is what low cohesion looks like. A much better situation is when responsibilities are distributed properly and each person is responsible for their own part. This is high cohesion. High cohesion means that each part of the system is focused on one clear responsibility, or at least responsibilities that are closely related. Together, these principles help you to move closer to separation of concerns. Separation of concerns means that your system, whether it is Salesforce or anything else, is divided into separate parts where each part is responsible for its own job and communicates with others in a controlled way. And the reason I say these principles help you to get closer to separation of concerns rather than achieve it is because there is no ideal state of separation of your application. You, as a Salesforce architect, must make your own decisions about what this separation of concerns will look like in your case. But to make this decision, you need to know the principles and preferably their technical explanation. Take, for example, the following line of code. There is nothing unusual in this, you might say, we just get today's state. And yet, such line of code has one important characteristic: it doesn't care from where it will be called from. That is, it simply exists without understanding where and how it is used. To counterbalance, take this line of code. We achieve the exact same goal, only in this case we pass a variable to which today's date needs to be assigned. The same result, and at first glance it might even seem that we still comply with the single responsibility principle because the method still works only with dates. But what is wrong here? The answer is that now this method knows too much about its surrounding. You see, modularity is the technique for reducing complexity by organizing your code into small, understandable parts, that is, turning such code into this one. But another characteristic of it is information hiding, meaning ideally a module, which is the class or a set of classes, should not know anything about other modules unless absolutely necessary. Your module bring real power only in cases when they carry a generalized motive. That is, they are not tied to specific surrounding functionality, but they just carry their own logic independently and just return a result. Now, take this example. We have a class that handles closed cases. At some point it generates a PDF summary and uploads it to the Google Drive. Here, the Google Drive service, which handles the upload, is tightly connected to this class. That means if anything changes inside Google Drive service, you'll probably have to make changes to this class too, or other way around. Or imagine you decide to start using a new storage provider, let's say AWS. Would you be able to switch to AWS without touching or making changes to this class? No, you wouldn't. And it might seem that with such new requirements with the AWS storage, you would always have to update this class. Nope. Let's refactor this class using some sort of magic. We add a new constructor that receives the iFile storage interface, not a class, but an interface. Now, instead of directly using Google Drive service as we did here, now the class uses the interface to upload files, which is obviously contains the upload PDF method. But how can we use the interface? There should be some sort of implementation somewhere, right? Absolutely. Considering our changes, now when creating an instance of the case close handler class, you first have to create an instance of the Google Drive service and pass it into the constructor. How is it related to what we're talking about? Bear with me. When a class like Google Drive service implements an interface, it is allowed to be passed anywhere where interface is expected, just like in our case close handler class. where we expect the iFile storage interface, which obviously wouldn't be the actual interface, it would be a class implementing this interface. And therefore, from this class point of view, it doesn't know which class will handle the upload and what functionality would be there. It only knows that whatever we pass in will definitely have the upload PDF method, because it is part of the interface. That means we can easily swap Google Drive service for another implementation, say AWS service, with completely different logic and a different storage, and this class won't have any idea about it. And by doing that, we have eliminated tight coupling, where changes in one class forces changes in another. Now the classes are loosely coupled, meaning they can evolve independently, and that's what makes your code more flexible, testable, and easier to maintain. Take this set of methods. All of these methods, as you can see, are related because they perform tasks related to dates. That's why Salesforce placed them in the date class, or we can call this class a module for now. Overall, a module is a vague term. It can be a single class or a folder with classes. Do not ask me. How would you react if this class started to contain a method like isRequiredOnLayout? It sounds useful, but this action would destroy the cohesion of this module. The thing is that if you have a module, say date, the functionality of this module must be related to each other. That is, the more related the elements on this module are, the better. For example, if you only work with dates here, then it's good, and it's called high cohesion, because all elements are doing the same thing, they're kind of related. But if you had a method like send email here, it would be called low cohesion, because you have methods in this module that do completely different things, and that's terrible, because you lose control over the code and how it can be extended and maintained.